So in the previous section, we addressed the use of color and how effective it can be and how much control you can have over it and how it affects your visualization. But as we said also, color is just one of the different elements you can use when you map your data into the screen. So then the question becomes, how many of these variables can we effectively use on the screen? So how many variables can we visualize? Well, you can really visualize as many variables as you want. You can create elements that show the different dimensions in a single graphic element. However, that doesn't mean that you're going to be able to understand each of these variables. You have to be very cautious of how you present this data. So how many variables can you understand? Is it 3? Is it 4? Well, let's talk a little bit about what it means just to visualize 4 data variables and how you would go about it. There was a really good study done by Colin Ware in 2009 that tried to encode 2 variables on a map. So that means you have x and y positions for different points in a map plus 2 different variables. In this case, we're talking about water temperature as well as water salinity. So here we have a map. You can imagine you have a grid on this. You can look at any data point. So you already have a latitude or longitude or an XY position. And then you actually decide to measure 2 different values on it. That means you have two more variables there for a total of 4 variables. So how can you map this? One of the first things that people think is like, if we're programming, and naturally in programming environments, when you do color, you have 3 elements available to you, red, green, and blue. And notice that we showed an example of what a red-green color map looks like before. So how about we map 1 variable to red and 1 variable to green? If we do so, we actually, by combining the 2 colors, you actually create this 2-dimensional color map. Now we actually apply this to our data, we get this result. Now imagine you're actually trying to ask how much information is in this particular point that's being highlighted right here in the middle. If you had a color beater that actually measured the color composition of your color map on your screen, you would actually get a fairly accurate value depending on the color performance of your screen. However, for the human eye, you would have to kind of just guess that you have this kind of muddy brown color. And then if you had to guess on the color map, you probably guess information somewhere around here. And notice if you ask the further questions, okay, but what does that mean in terms of red and green? Well, one of the things you can do is simply map this to each of the axes, or you could try to guess how much it means in the red scale and in the green scale. And of course, you can realize quickly that probably humans are pretty bad at doing this. It's hard for people to be really good at determining how much red or green is in one particular color. So it turns out a better way to do something is to use hue separate from value. In other words, use the tint color versus how much black is in there. And as we saw before, really the luminosity of it carries a lot of information. So now we look at the same point right here, well, we see this is definitely some kind of purplish color, and we can see it's pretty dark. So our guess would be somewhere around that value. Well, what Colin decided to do is like, well, let's go ahead and treat this a different way. How about we treat 1 variable separately from the other variable, and rather than trying to combine it in the single color, let's create bins of these grid points into higher 3x3 or 9x9 bins, and actually show a visual element laid on top for 1 variable, while the other one's in the background with a color map. That's exactly what he did. For 1 variable, here in the x-axis, you actually have the hue, which is easy to tell, which is semi-straight to tell forward, to tell. Well, in the other one, we're using these dark circles, going from a small circle to a big circle. And notice that means you're binning the data for the second variable to actually be able to show information for many pixels or many data points at once. So now, if you ask information for this right here, you can pretty much straightforward say, okay, that's definitely the 4th circle from the bottom. That's how big it looks. And it's definitely some kind of cyan color. So that would be your guess. You still have to judge the size of the circle. So how about we make it a little easier, and instead of doing that, we go ahead and use very distinct shapes. So rather than having a continuous range for circle size, we do very continuous binning even in the normalized values for the second variable. So we use distinct shapes going from this minus to this plus to this half asterisk to this full asterisk. So now we look at the same spot, we can tell that's definitely not the small dash, but the larger dash, and it's the black one. And it's the same cyan color that we saw before, so we would definitely put this guess right around here. You can use shapes that are less intrusive to each other, so use even completely different shapes, and you would get some similar results as before. So what was the point of this? Well, now you can ask people, okay, tell me the combined value for both variables, and you can ask them as well, okay, well, tell me the value of the first variable and tell me the value of the second variable when you saw each of these points. Now you can compute the error for each of these our different approaches, and as it turns out, while value was definitely good for one of the variables, for the most part, yes, people had problems separating between the two variables, both in the green and red, as well as the one where you use hue. It was just hard to discern one variable from the other variable when you have this continuous range. Now, the moment we took this into this bucketed system or this bin system, things got a lot better. The error went down quite a bit. So even though you're actually losing some information by binning this data, by discretizing it into 9 buckets or 10 buckets, by showing distinct things that can be easily separated from each other, you're actually conveying much better the sense and understanding of your information. The takeaway message from here is that a lot can be said about the way you design something and approach something. That doesn't mean you have to use each of your available variables to the full extent. Rather, it's very much a design-conscious decision to how you approach each of these variables and how you decide to map each of your variables to the screen. And again, the issues of dominance and of layering and proximity and space, all these come into play when you design your visualization.